All right, so what's our difference between crystalline and amorphous solids? A super easy answer would be what? So we got
You also said that amorphous solids were sort of like super viscous liquids.
sure, you could say really, how about the other important part about this is the pattern is repeating. So it's the same type of unit cell over and over again. Why are impurities not necessarily a bad thing? What kinds of things could adding impurities to a pure substance do for you?
Strengthen.
All right, so you can add strength,
Flexibility.
or if the substance is too strong, you could add flexibility. Anything else?
Can make it lighter.
Oh yeah, you can change density.
The properties of other materials by making
Like what?
bronze.
Like what property changes?
Oh,
What are you doing?
with steel, it's a lot harder than iron.
You could change the luster, or you could change the color of it, right? When you guys did the penny experiment, you changed it to silver looking, then you changed it to gold looking. The hardness is really just strength, but you could change the reactivity of it. So you could make it less corrosive, less like zinc is super corrosive, but if I add copper to it and turn it into brass, then the brass itself, it's a lot harder to rust brass than it is to rusting zinc is simple, rusting brass not simple. So you can change the actual chemical characteristics of the substance. Because copper doesn't rust, zinc does rust, put them together to make brass and you get something that doesn't rust. Did you guys look this up and figure out this one? What do you got?
The sold folding increases decreases the impurities of the steel or iron, and like helps increase strength and stuff.
You end up increasing the strength for sure,
Yeah,
but what you're doing,
it's being folded on itself, being reheated, folded, beaten, refolded.
that's exactly it. You picture a blacksmith beating down on a sword, it gets beat down super flat, and then he turns it on its side and folds it in on itself. And in doing that, you get this kind of interstitial. So the atom is no longer in a nice straight line. So what's that end up doing for your sword? Make it stronger. So you can make it smaller, but what's the problem with making it strong?
It can flex.
It won't flex. So if you hit something hard enough, the sword's just going to snap on you. So there's your drawback for having something super strong. It could just snap. The word defect sounds bad. It just means in the technical sense, in the scientific sense, it just means a change in the regularity. It doesn't mean that it's terrible. Like you definitely don't want like a defective car, but having defects in the metal on your car, not a bad thing. Gives it more structural strength. Just not too many, then it becomes too rigid. So increases the spatial defects in the sword, adding strength. But the decreases flexibility. All right, so we're going to do one for water. So I've got pressure, I got temperature, kind of like that, kind of like that, kind of like that, solid, liquid, gas. So melt, freeze, vaporization, condensation, sublimation, and then deposition. And then we'll go triple point, critical point. How about this one about viscosity and changing your motor oil?
Thinner motor oil, be better when it's colder.
Yeah. So if it's cold, I want what am I doing? Lighter or thinner? What happens if you don't change it to a thinner oil and it's really cold outside?
Just get clogged.
Not clogged. What do you mean by bogged down?
Just like, you know, make the engine crack. It'll be like too quick.
Well, when?
When you're starting.
Just when you're starting it. That's really it. You decrease the thickness of it, make it lighter, so when you go to start the car, you don't kill the battery. If that oil is really like molassesy, when you go to try to start the car and the starter motor is trying to turn the crank through that thick oil, that you just suck the battery dry and the car doesn't actually start. How do people who don't change their oil to different weights get around that? Like me, I don't change the oil in winter. Does anybody know how that giant truck doesn't bog down when it's cold? It's plugged in. I thought it was a heater too, but I found out it's not a heater at all. It just makes the oil pump move all the time. So it's always kind of moving. And so when I go to start the car, it didn't get a chance to settle and like have strong intermolecular forces with itself. I'm constantly just mixing it up. They do have heater blocks. Like if I'm going to move to Alaska, I'd probably put a heater block on it. But this one literally just moves the oil pump very slowly. It's way worse for diesel cars because the diesel motor is always going to be heavier than a regular motor. Although I was really shocked I hadn't moved our tractor for like 2 months, a little more than 2 months. And that little thing just, bam, just started right up. It was amazing. It's like a 40-year-old Kubota. Makes me want to just buy Kubota stuff. Sometimes with those diesel motors, they have other ways to heat it up. Like on that tractor, I couldn't just start it. I actually had to turn it to the left first. And what that does is, if you look at the back of a hairdryer, what do you see? Anything else? A fan, a little grid of wiring mesh. What else? Lint. Yeah, okay. All right, now we're getting a little gross, but what else we got there just underneath that? A coil that's probably orange from the heat. That's what diesel cars usually have on them, and those are called glow plugs. Depends on the car, but on my truck, I just turn it to the first spot, and you'll get this little coil thing that pops up on the dashboard, and after like 10 seconds, it goes off, and then I can start the car. What that did is it ran, it looks just like the hairdryer coil, and they're embedded in the block, like you screw them into it, and the battery just runs electricity through it, and it gets hot, heats the block up, and thereby heats the oil up, gets it a little thinner, and then it works. So the same thing with that little tractor. I just ran the glow plugs, and then bam. Completely different thing. The glow plug only works when it's cold outside, when you're first starting the car. It's got nothing to do with operation running. And then in the summer, what do I want to do? I want to put thick oil in there because I don't want the oil to be, I want it to not vaporize. So if it's too hot, then you'll actually have the oil kind of boil off, turn into a vapor, and I don't want that to happen. I want that stuff to stay stuck together. Anybody ever had the pleasure of taking a wheel bearing apart? That grease that's in there, if it touches you, you're stuck with it for like a week because it just doesn't come off. But it's also ridiculously thick. Like if you put a spoon in it, it's thicker than peanut butter. But think about what's happening with that wheel bearing. It's constantly spinning. It could be spinning at 80 miles an hour for hours as you drive through Montana. I can't have that stuff get liquefied. It's got to still stay goopy. So the molecule that is that wheel bearing grease is very long, and they really like to stick to each other. Very nonpolar. Write the vapor pressures of, okay, what do we got? So the ethane, it's CCH. And would you say 5?
45.95, 75.95.
I'll just put 5.9.
KPA.
Anybody get the ethane?
It's like 475, like.
That seems to make sense. What are you doing? Why is one so much larger than the other? These questions are all about one topic. Do you know what the one topic is? Oh, intermolecular forces in general. This one has hydrogen bonds on it. This one just has dispersion forces, and it's a tiny molecule. So how strong are those dispersion forces? Not. So if I actually liquefied ethane, the pressure over the top of it in gas would be 100 times-ish, a little less than 100 times greater than if I had a container of water or of ethanol, and the pressure over the top of that would be 100 times less. Simply because they don't like to stick to each other as much. The ethanol has the hydrogen bonding, so it's more likely to stick to another. So another ethanol would be happy to do this right here. This connection and that connection would cause those guys to stick to each other. When I've got the two ethanes next to each other, like we're just dispersion forces. We can move some electrons around, but not very many because there's only 16 total electrons to move. That's not enough. And they're not localized. Okay.